Hey! So today's lesson is dividing polynomials or polynomial division, and we're going to incorporate that into our rational functions and merge those two together. When we did our polynomial units, we didn't get too heavy into this. I knew we were going to touch on it later, which is now. So we're going to do this now. Just a brief intro into it, and we'll keep doing it throughout this week and next week. And then we'll talk about how that applies to our rational functions, and we'll head over there and do another one. Okay, here we go. M minus 8 going into m squared minus 7m minus 11. Now, what if I told you that these were exactly the same steps? Only you just need to know where to look, okay? So the first thing, or first place to look is right here. It's like the 7, okay? So how many times is 7? And we went into 10. So I want to think about how many times does m go into m squared. I'm not going to bite off the whole chunk. I'm just going to do a part, right? Well, that's easy. You multiply m times m, you get m squared, okay? Write this down on a piece of paper and draw these little columns right here to separate the terms. You notice you have a squared column, a linear or m to the first column, and then a constant. That's an 11 over there. Sorry, it's not a very good 11. There you go, okay? So when you say m times m is m squared, you'd want to put that in the appropriate column. You want to put it in the m column, okay? Or the linear column. Now we have to multiply this back, just like I did with the 7. I took it, I said it went in one times 7 is 7. We have to multiply m times this, okay? So that m times m is m squared, and m times negative 8 is negative 8m. Okay. When you got to this line of the division problem, what do? You subtract. I like to use a different color. Subtract both terms here. You got to subtract both. Think of like distributing the negative to both those terms. What's really nice right here is this cancels, which is what's supposed to happen. And then you're going to subtract the like terms, 1m, and bring down. This should look really familiar. Okay? Same steps as it was before. Don't try to bite off the whole chunk. Just make m look like 1m. Oh, wait. It does. This is 1m. So what would you multiply m times in order to keep it as itself? That's simple. Plus 1. Notice that went in the appropriate column. Okay. Distribute 1 back to this binomial. 1 times m is 1m. 1 times negative 8 is negative 8. Draw a line. And change your signs, because you have to subtract this thing down here. So minus, plus. This cancels. And you're left with a remainder of negative 3. Okay? Now that remainder usually goes over this, right? The divisor. So we're going to put negative 3 over that. Let's do number 3 off of the worksheet. N plus 5. Going into n squared plus 10n plus 18. Know where to look, okay? All you have to do is make n look like n squared. Hold on. Consistency is good. Remember I told you to draw those columns? We should probably do that again. N times n is n squared. I'm going to put that right here in the n column. N times n. That's good. N times 5. Don't forget to distribute that to both terms. And when you draw your line, you have to subtract both. That's the one that most students forget to subtract right there. They might do the first one because that's like how we divide. But they'll forget to do that second one. Let's not forget to do that second one. Carry that through. Cancel. 5n plus 18. Bring down. And look right here. Always look at the leading term of what you got. And try to make the leading term of this one look exactly like that. Well, what would you multiply by? You take it times 5. 5 times n, 5n. 5 times 5, 25. Draw a line. Subtract, boom, boom, both terms. Cancel. And you have a remainder of negative 7. Now, if you care about the remainder, it goes over n plus 5. So minus 7 over n plus 5. But remember what I told you today. For these guys, we don't care about the remainder, so it even simplifies things more. Okay, let's take a look. There's one like this in your Desmos activity. I said if the degree of the top is more than the degree of the bottom, it's a slant. Remember, if the denominator, so if numerator is less than denominator, it's the x-axis. If they're the same, you have to divide the coefficients of those terms. If this is greater than the denominator in degree, it's a slant. Okay? So we have to divide to figure out where the slant is. Oh, okay. So we're going to do this. X minus 2 goes into x squared plus 2x minus 8. How do you make x look like x squared? Well, that's like the same beginning as we had begun over here with the other two. Gotta draw my columns. X times x is x squared. Distribute x back to these two. You've got x squared. X times negative 2 is negative 2x. Subtract. Oh, I gotta use a different color. Hold on. Draw a line. Minus plus. Cancel. 2 plus 2 is 4. 4x. Bring down. Okay. How do you make x look like 4x? That's the leading term. That's all you really care about when you're trying to decide what number to put down next. That's times 4. So plus 4 right there. Distribute that back. You've got 4x. And 4 times negative 2 is negative 8. Draw a line. Ooh. Minus plus. Cancel, cancel. Remainder 0. Oh, x plus 4 is a factor of that trinomial. Oh yeah, that makes sense. If you multiply x plus 4 times x minus 2, you get that when you do double distribution. See how I made it appear that I didn't know it was going to happen when I knew it was going to happen the whole time? Okay. All right, we're at that part of the show. He gets mad at me every single time. Here, hey, would you mind helping me out with this? Hey, can you throw it over there? Hey, Mini-Me, can you hand me a 2x6?
Oh, throw the marker?
He gets mad at me every time I throw it.
All right. He did it, not me.
I didn't do it, he did it. My bad. Sorry. Okay. So this one is in the Desmos activity today. It's pretty simplistic. All I need you to do is think about those 5 areas. Remember, number 1 is y-intercept, set it equal to 0. Or, sorry, plug in 0, my bad. Number 2 is take the top and set it equal to 0. See what you get. Over here, vertical asymptotes, set x equal to 0. That's easy. And then when you get to number 4, it's not the x-axis for the horizontal. It's not they're not equal. You got the degree of the top is greater than the degree of the bottom, so it is now a slant. Okay, so you're going to take x into x plus 1 or x squared plus 1, and notice that there's no middle term here. Okay, so you'd actually open that up and say 0x plus 1. Because you need something in that place. Remember the columns, there's 3 columns. So for those 3 columns, you have to have an x column, okay? Make x squared look, so make x look like x squared. Sorry, struggling with that. And that would be times x, and notice it's gonna go in this space, okay? Multiply this back, you get x squared, and then it'd be x times 0, which is just 0. That's easy. Subtract, cancel. And when you get to here, like, it's 0 plus 1, but you don't have to make x look like 1. You're already at the remainder, okay, of this, which would be a 1. So I'm just going to say it's y equals x. All right, so see how we got x out of that? Number 4 is y equals x. So you need to put that into Desmos and see if the slant, if you type in y equals x in the function, does the slant make the asymptote where it's approaching on both ends? Take a look at that right now. Okay, we good. Marker toss time. This guy's bad. He's been resurrected. Okay, I'm just going to start recording. And I think it's recording now. I don't know where it saves to, but I'll take a look at that.
Okay.
So you just chuck it in from your right side.
Okay.
But try to keep your hand underneath the video. Yeah. There you go. Perfect.
Okay.
Okay. And try to like catch it and be like, hey.
Okay. You know? So okay.
All right. And then the next thing I would say to you, just kind of look down to your right.
Okay.
Like more. Yep, right there. That's good.
Like down.
Yep, just like that. And I'll say, hey, can you help me with this? Can you just throw it over there? And you're like,
I just throw this way.
Yep, that looks good. Yeah. And I'll say, you can like question me on that. It's like, are you sure about this? Like, yeah, just go ahead and throw it. So then you throw it, pause for a moment, and then we come back to you, and you're like, he did it.
Okay.
I'd be like, I didn't do it. He did it.
Okay.
Okay. Something like that.
All right.
All right, go ahead.
Okay. So let's see. All right. Should I watch it coming in? Yeah, I'll watch it.
Okay.
Do you see that?
Yeah.
I shouldn't talk. Let me try to get without talking. Hold on.
You see it?
Okay.
Hold on. Can I get me off the screen? That's perfect. Okay, keep going.
All right, so
do it again.
Okay, so I should throw it. Then you want me to wait and look down, or wait for you to say something?
Wait for me to say. I'll talk you through it.
Okay.
Okay.
All right,
go ahead.
Go.
Yep. Hey, can you help me with this? Just throw it over there. He always gets mad at me when I throw it. You throw it.
Throw the marker?
Yeah, throw the marker.
All right. He did it, not me.
He did it.
There's him. Okay. It's like working with a green screen or something.
I know.
I now have a lot more respect for like Tom Hanks and those guys.